Hello, this is a video on marginal analysis, and after this video you should be able to do the following. Given a cost equation, you should be able to find the average cost and evaluate. Given a profit, revenue, and cost function, you should be able to find the marginal profit, revenue, and cost function. Given a marginal profit, revenue, and cost function, you should be able to evaluate those marginal values and explain the meaning in the context of the problem. And then, given a marginal cost and average cost at a particular quantity, you should compare and contrast the values. So we'll start with a cost function that is not very difficult to take the derivative of so that we can really nail down the interpretations. So we're going to let c of x equal 3x squared plus 9. It's a total cost function where x is the number of items produced. Then the derivative of this cost function, c prime of x, is known as the marginal cost. And so the derivative of this function is 6x. So c prime of x equals 6x. That's the marginal cost expression. Now the marginal cost measures the approximate cost of one additional item. So you can use this marginal cost to calculate the approximate cost of the next item. So if I asked you to find the cost to produce the 11th item, what that means is you take the derivative of the cost function and you don't plug in 11, you actually plug in 10. And so c prime of 10, 6 times 10 is $60. And that is, the interpretation is this: it will cost approximately $60 to produce the 11th item, since it's the next additional item. Now, I might help you understand this if we do recall that the derivative of a function is the instantaneous rate of change. And so there is a way to interpret this using the instantaneous rate of change, and that interpretation would be this. At 10 items produced, the cost is increasing at a rate of $60 per additional item. Well, if you're at a level of 10 items produced, that additional item would be item number 11. Now here's the tricky part. You must interpret the marginal cost differently than the IRC, even though they're the same thing. This is something that we do in Math 263. The marginal cost gives the approximate cost of the next or the 11th item. So in context, if I ask you to interpret the marginal cost and you interpret it the IRC way, you would be technically right, but you get points off. You have to understand and demonstrate that you understand that the marginal cost is the cost of the next item. But you know, the IRC can help you understand that, because at 10 the cost is increasing at a rate of $60 per additional item. So the marginal cost interpretation for c prime of 10 would be that $60 is the approximate cost of the 11th item, and the other direction works too. If I want to know the cost of the 11th item, I evaluate the derivative at 10. Let's try it again. Same function. The cost function, 3x squared plus 9. The derivative would be 6x. If I asked you what is the marginal cost at a production level of 8 items, I'm telling you that 8 is what you want to evaluate at. So c prime of 8 would be 6 times 8, that's $48. Now to interpret that, since it says marginal, you would say that it will cost approximately $48 to produce the 9th radio. So that is marginal cost, and that's the approximate cost of the 9th radio. Now there is a way to calculate the actual cost of the 9th item. If you have a total cost function, what you can do is take this function that relates number of items to total cost, and you can evaluate at 9. And so 3 times 9 squared is 3 times 81 plus 9. That's $252. So it's going to cost you a total of $250 to produce the 9 items. Well, if you evaluate at 8, 3 times 64 plus 9, that's $201. It's going to cost you a total of $201 to produce 8 items. Well, if you subtract the total cost to produce 9 minus the total cost to produce 8, you get 252 minus 201, which is $51. That's the actual cost for the 9th item. Okay, so if you understood marginal cost, the same exact thing is true for marginal revenue. If I ask you to find the marginal revenue, that means take the derivative of the revenue function, and the interpretation would be that the marginal revenue is the revenue gained from the sale of an additional item. And if I asked you to find the marginal profit, you would take the derivative of the profit function and you interpret the marginal profit as the profit from the sale of one additional item. So if we've got specific numbers in here, if that was a 90, then the marginal revenue would give you that value that you would get would be the approximate cost of the 91st item. If excuse me, I said approximate cost. It would be the approximate revenue gained from the 91st item. If I put a number like 45 in here and I asked for the marginal profit and I got a value, that value would be the profit gained from the 46th item. Okay, so let's look at the lab manual. Marginal analysis section. We're going to look at number 1. Okay, so from your lab manual, marginal analysis, number 1 says a manufacturer has determined that the cost and revenue in dollars to produce and sell X items are given by the respective function C of X equals 2x cubed minus 12x squared plus 40x plus 10, and the revenue function is R of X equals 50x. And we're asked to state the profit function. So we know that our input variable is X equals number of items, and so that input is going to stay the input throughout the life of this problem. And we want to find the profit function, so we know profit is found by taking a revenue function minus a cost function. So our profit function is the revenue function 50x minus parentheses 2x cubed minus 12x squared plus 40x plus 10. So we have to distribute that negative. So that would be 50 plus a negative 2x cubed plus a positive 12x squared minus 40x minus 10. And so then if we collect like terms, we will have, I'll put it in descending order, negative 2x cubed, and then positive 12x squared, and then positive 50x plus a negative 40x is 10x, and then minus 10. Then it says what are the cost, revenue, and profit values for selling 2 items. So we've got a cost function that we would want to evaluate, C of 2, and a revenue function that we would want to evaluate, R of 2, and a profit function that we would want to evaluate, P of 2. So you need to know that that is just using the original functions that relates number of items to cost and number of items to revenue and number of items to profit. So this is not a derivative question. And I'm just going to wait till I get into Excel to evaluate those, even though some of them are easy. But question C says, what are the marginal cost, marginal revenue, and marginal profit values? So you need to know that that means take the first derivative of each of these. So I'll do that here. So the derivative of the cost function, C prime of X, the cost function is right here. So the derivative of 2x cubed is 6x squared, and the derivative of minus 12x squared is minus 24x, and the derivative of 40x is positive 40, and the derivative of 10 is 0. And we want to know the marginal cost for two items, so we would then plug 2 in. Let's go ahead and find the marginal revenue function, and that would be, here's our revenue function, 50x, so the derivative of 50x is 50, and the profit function is right here, so that would be the derivative of negative 6x squared plus 24x plus 10. So I'm going to put these into Excel and come back and interpret all of these things. Okay, so now we're in Excel, and this question, you need the original and the marginal profit. So I'm going to go ahead and let column A be my input, which is X number of items, and then I'll go ahead and put in a revenue function, cost function, profit function, marginal revenue function, marginal cost function, and marginal profit function. And both questions are asking me to evaluate at 2, and my revenue function is 50 times x, which is 50 times a2, and forgot to hit enter. There we go. My cost function, original cost function, is 2 times x cubed minus 12 times x squared plus 40 times x plus 10. And my profit function, if I've already written down the algebra, I'm just going to use Excel's capabilities, and I'm going to do revenue minus cost. And then my derivative, Excel doesn't take derivatives, so I found that the derivative of revenue was 50, and the derivative of the cost function is 6 times a2 squared minus 24 times a2 plus 40. And you can't subtract, sometimes you can, but I would never think about subtracting this revenue minus this cost column. I would just type in the brand new derivative. So it would be negative 6 times a2 squared plus 24 times a2 plus 10. Some of our derivatives are going to get quite tricky, so I don't want you to get in the habit of subtracting these two derivatives to get the derivative of the profit. That's a bad habit. Okay, so now it's time to interpret each of these values, and you should write all of these values in your lab manual. If we look at the answers here, then we'll have a better idea of what everything is. And that is not good, so let's move this back. Okay, so we did A. All right, B says what are the cost, revenue, and profit values for selling 2 items? And for C of 2, I got $58, and R of 2, I got $100, and P of 2, I got $42. And then what are the cost, marginal costs? And at R prime of 2, I got 50 right here, and C prime of 2, I got 16, and P prime of 2, I got 34. Okay, so interpreting each of these, let's do cost first. This is a marginal cost right here. See, remember, that's a marginal cost, so you evaluate it at 2, but what it tells you is that it's the approximate cost of the third item. So it's going to cost you approximately $16 to produce the third item. And then here is the marginal revenue. r prime of 2. But it's going to tell you the approximate cost of the third item. And this is marginal profit right here. So evaluate at 2 is going to tell you the approximate profit of the third item. So it's going to cost approximately $16 to produce the third item. The revenue made would be approximately $50 for the third item, and the profit would be approximately $42 for the third item. Now, one note about this revenue, remember that you took the derivative and it was the constant 50. So you can go further with the revenue. The derivative evaluated at 3 would be 50. So the approximate cost of the fourth item would be 50, and the derivative evaluated at 5 would be 50. So the approximate cost of this, or the revenue, would be $50 for the sixth item. So this is telling you that every additional item is going to cost about $50 here for this revenue. Okay, so we just did number 1 in the lab manual. And before I move on to average cost, I did want to mention something. In this slide, you may have just been wondering where the radio came from. That's just a mistake on my part. We were talking about items, and I changed it to radio on you, and for no reason other than after you do number 1 in the lab manual with me, you should try number 2, and number 2 is about, you might have guessed it, radios. So that's actually why I accidentally put the radio in there. But anyway, let's move on to average cost. And so average cost is a special function, and it's the average cost function, and it's denoted with a bar on top of the C. You might know that from statistics. X bar means average. Well, C bar means average cost. And average cost is calculated exactly the way you might think. If you know the total cost to produce X items, then you just divide that by X. So that's how you calculate an average cost function. It's just the same way that you would find your average test grades. You would add up all your tests to get a total test value and then divide by the number of tests. Well, average cost is total cost to produce X items divided by X. And the average cost gives you the cost per items when you've manufactured that many items. So the units on average cost are going to be exactly the same as IRC because you're taking the total dollars and dividing by the number of items, so the units would be dollars per item. Okay, so let's say I give you a cost function. It's understood a cost function is a total cost function. Then if I wanted to create an average cost function, a C bar of X function, I would take that total cost function, 3x squared plus 9, and divide that by X. And that is now an average cost function. So then if I asked what is the average cost per item, when producing 8 items, I would take that average cost function and put 8 in and do the math, and it comes out to be 25.13, and again the units would be $25.13 per item. And what that means is if you produce 8 items, then it's going to cost you $25.13 per item. So if you multiplied 25.13 times 8, you would get the total cost for all 8 items. So this is your average cost per item. Now, what we can do is we can compare average cost with marginal cost. But now let's just review for a second. So if we let C of x equal 3x squared plus 9 as our total cost, and the derivative or marginal cost is 6x. Remember, x is number of items, c is total cost to produce x items. If we let x equal c, let's make sure that we know how to interpret. So what are each of these and what do they mean? And when applicable interpret the marginal cost. Okay, so the first one, what does C of 8 equals $201 mean? Well, that's the total cost function. So 8 is X, so when 8 items are produced, the total cost is $201. Then we have C prime of 8 equals 48. What does that mean? Now this derivative could mean IRC, but I want it to mean marginal cost, so you have to interpret in that context. What does C prime of 8 equal $48 mean? Do you remember? It means the approximate cost of the 9th item is $48. Okay, then we have a new one. C bar of 8 equals $25.13, and technically I should remove that. Shouldn't give you any hints. That's only a partial unit. What does that mean? That bar means average cost. So how would you interpret that? That means at a production level of 8 items, when you manufacture 8 items, the average cost is going to be $25.13 per item. And then finally, what does this mean? C of 9 minus C of 8 equals 51. Well, C of 9 is taking the original total cost function, so that means the total cost to produce 9 items. This is the total cost to produce 8 items. If you subtract that, you get $51. What does that mean? That is the actual cost of the 9th item. It's $51. Okay, so now let's compare the marginal cost and the average cost. So let's consider these two things. The marginal cost at a production level of 8 items is $48. That means the 9th item costs approximately $48. And the average cost at a production level of 8 items means that it costs you about $25.13 per item when you produce 8 items. And the question that this answers is something like this. Should the manufacturer produce a 9th item? This is your average cost when you're at 8 items produced, about $25. But to produce the 9th item, it's going to cost approximately $48. What is going to happen if you produce the 9th item? Well, in general, what that's going to do is that's going to raise your average cost, because it costs more to produce the 9th item than it did to cost to manufacture on average the 8 items, $25.13 per item. So in general, if the marginal cost is less than the average cost, then the average cost is going to go down as your volume, which is number of items, increases. So as you make more items, the marginal cost is, if it's lower than the average cost, then the average cost is going to get pulled down. And if your marginal cost is greater than your average cost, then the average cost is going to go up as the number of items increases. And I cannot do better than the book explaining this. So here's what it says. It says average cost and marginal cost convey different but related information. The average cost, C bar of $50,000 equals $18 that we calculated in example 4, is the cost per item of manufacturing the first 50,000 music players. Whereas the marginal cost, C prime of 50,000, is equal to $10 that we calculated in example 1. It gives the approximate cost of manufacturing the 50,000 and first music player, the next player. Thus, according to our calculations, the first 50,000 music players cost an average of $18 to manufacture, but it costs only about $10 to manufacture the next one. Note that the marginal cost at a production level of 50,000 music players is lower than the average cost. This means that the average cost to manufacture CDs is going down with increasing volume. And this is why I'm showing you this page. Figure 6 shows the graphs of average and marginal cost. The red graph is your average cost function. And you see as volume increases, your average cost is going down. And the blue line is your derivative. And see how it's below? And it seems to be pulling down that average cost with it. And this is something that is true in general. If you manufacture many items, they're not custom, you just are able to manufacture a lot of items, it's going to make your average cost go down as volume increases. It's not true all the time. But this illustration you want to just kind of look at and memorize. If the derivative is lower than the average cost, it's pulling your average cost down. So it's a really general question. There are a lot more variables. But should the manufacturer produce a 9th item here, it's going to cost him more money. Excuse me, that you may have heard my dog. Sorry about that. So again, to sum up, technically there's a lot more variables, but if you're going to produce the 9th item, it's going to raise your average cost. So you may want to think twice about producing more. Okay, so now we will do number 2 in the lab manual. Okay, so we'll do example 2 together. The daily cost in dollars of producing X radios is C of X equals this polynomial. The question A is, what is the daily cost at a production level of 40 radios? And this is a daily cost function, so this question is asking us to use the daily cost function, not the derivative, and evaluate at 40. So we would want to do this, and I'm going to use Excel to do that. The units, X is radios, that's my input, and C is cost in dollars, or daily cost in dollars. So my units here, that's going to be 40 radios, and we're going to have a value, a monetary value. The next question is state the marginal cost function. So that means take the derivative of that daily cost function. So that would be C prime of X equals, I don't want to use my calculator, so I'm going to use the constant rule and bring down my constant, 0.002, and then take the derivative of x cubed, which is 3x squared, and then 0.1 times 2x, and then 42. That's our marginal cost function. And then the marginal cost at a production level of 40 radios, think about that. They're telling you the level, so you would plug in C prime of 40, and we'll use Excel to give us that value. And then we're going to interpret that answer. So see if you remember, if you're evaluating at a level of 40 radios, this is giving us the approximate cost of the 41st radio. So I'm going to go ahead and write that out, even though I don't know the value yet. Approximate daily cost of the 41st radio is, we'll figure that out in a minute. Then it says find the average cost function, the average daily cost function. So here we have our cost function. You remember how to find the average cost. C bar of X is equal to this function divided by X. And then this last question here, compare the average cost and the marginal cost at a production level of 40 radios. So we have this value we're going to use, and we're going to need to evaluate this at 40. You might want to go ahead and divide this monomial in to each term. So I'm going to do that. C bar of X is 0.002. X cubed divided by x is x squared. And 0.1x squared divided by x is 0.1x. And 42x divided by x is 42. And 300 divided by x is 300 over x, or 300x to the negative 1. So now I have the average cost function, and I'm going to evaluate it at 40, and those units would be dollars per radio. And I'm going to compare these two. But I'm going to take it to Excel to do that. Okay, so let's put everything in. So this is X radios. And then we have a cost function. And then we have a derivative, which is marginal cost. And then we have a C bar function, which I'm going to put in as C bar, like that. And the cost function is 0.002 times A2 cubed plus 0.1 times x squared plus 0.1, plus 42 times x plus 300. And then I'm going to check it. Make sure I have the right number of zeros here. That's a common error. 0.002, 0.1. Yep. Okay, so I'm going to hit enter and just make this bigger. Okay, and then my derivative is equals 0.002 times 3 times x squared plus 0.1 times 2 times x plus 42. Check that. Right number of zeros. Don't need parentheses here because it's all multiplication right here. Sometimes people put the parentheses in front of the 2, and that's bad because then that 2 ends up with the 3. So be careful about that. Okay, that looks right. And then my C bar function is 0.002 times x squared plus 0.1 times x plus 42 plus 300 times x caret to the negative 1. So we have that. And question A says, what is the daily cost at a production level of 40 radios? So the daily cost is $2,268 if 40 radios are produced. Second one, marginal function, we did. C, what is the marginal cost at a production level of 40 radios? That's $59.60 to produce the 41st radio. And then E, we found the average cost, and what is the average cost at production level of 40 radios? So at a production level of 40 radios, the average cost is, the units are dollars, $56 per radio. That's how much each radio is going to cost. Each of those 40 radios cost $56.70. All right, and then finally, it says to compare the average cost and the marginal cost. What does the difference between the two values tell you about producing radio 41? Well, the marginal cost is $59.60, and it is higher than the average cost of $56.70 per item. So that means this is your average cost to produce 40 items. Well, the 41st cost more. So that means that the 41st item is going to make your average cost go up. And so I have work here, and this is how I wrote that. The average cost at 40 radios is $56.70 per radio. The marginal cost at 40 radios is $59.60. This means that the 41st radio costs more than the average and will raise the average cost of production. So you can read through everything that I've written here to help you out. That's the last example. You should do problems 3 and 4. And get in a good habit of checking what you're typing in. And if you get an unreasonable answer, like on the first test, some of you were unable to find break-even points because of typos. So if something crazy happens, check for typos. Check for bad algebra. I know you're probably doing that, but things are going to work well. We've vetted the problems. They're gonna work reasonably well. So if they don't work reasonably well, you made an algebra error, you made a typing error, and sometimes you've made a huge concept error, and that's a big deal. But try to find the little errors. Okay, so do 3 and 4. Have fun with that, and then we'll see you the next video.